Hello, pre-calculus students and general seekers of truth. We continue our study of functions with piecewise functions. So let's get at least a layman's definition here for what a piecewise function is. Right? So a piecewise function is a function that is made up of two or more other functions. So it's still a function. It follows all the rules of what a function is, but it's just a special case that we need two or more functions to describe it. So I have an example here. F of x is equal to 2x minus 1 when x is less than 0, and 3x plus 1 when x is greater than or equal to 0. So one thing that I'm going to start with when I graph these functions is the endpoint, or the point where the function switches from one piece to another piece, right? Because that's always a critical component of this. So if I have x and f of x, right? So let's say right at 0. Right at 0, I'm sorry, let's go with a negative number. So let's say at negative 1, we're using the top line here. So this is 2x, or 2 times negative 1 minus 1. So that's equal to negative 2 minus 1, so that is negative 3. All right. At 0, I'm going to use this function here. So that's 3 times 0 plus 1, so that's equal to 1. And then right past 0, if I have 1 here, that's 3 times 1 plus 1, so that's equal to 4. And then let's go one more, maybe another negative number, negative 2. So I'm using the top line here. So this is going to be 2 times negative 2 minus 1, so that's going to be negative 5. So with this, I'm going to use a scale of 1 to 1 here, 1 on the x-axis, 1 on the y-axis. I'll be able to draw a graph. So negative 1, negative 3. Negative 1, negative 3. 0, 1. 3, 1, 4. So 1, 1, 2, 3, 4. And then negative 2, negative 5. So this is negative 1, 2, 1, 2, 3, 4, 5. Okay. And then I can kind of fill in the rest of this. And I know that this is two linear equations. So the one to the right, I can draw it out as follows. I can just start here and go up this way, right? And then the one on the left, now the one on the left is a little bit more difficult, because if I follow this trend, it should look like this. It should go this way. Okay. So the line here on the right, that is 3x plus 1, and we can check this. This has a slope of 3 and a y-intercept of 1. The line on the left side here, on the negative side here, is 2x minus 1, so a slope of 2 and a y-intercept of negative 1. Except something unusual, or at least something that we have to pay careful attention to, is that at 0, right? At 0, you see that there's actually 2 points here, one down here, one up here. And that doesn't work because that violates the definition of a function. So what we need to do is to clarify the graph, we need to put an open circle here. That means that this line gets really, really close to x equals 0, but does not actually touch it. This line here does not actually touch x equals 0. When x is equal to 0, I'm going to emphasize this dot here. We jump from this line up to this line. So this is what a piecewise function looks like. And again, it's actually important to figure out this endpoint here, this point here at when x is equal to 0, because that's where it switches over. We're going to use 2x minus 1 for every number up to 0, but not including 0. And then at 0, we're going to use the second part of the function 3x plus 1 for that. Right? So that's a nice starting example here for a piecewise graph. All right, so I'm gonna end this video here, and we'll do one more problem in the lesson.